I've had a lot of people ask me some questions on 10.5 homework, so I'm just going to go ahead and make a video on it. So let's just start off with number 2. This is going to be a longer video, so if you guys just want to skip around, if you don't need help with 1 through 6 or 2 through 8 or whatever, you can just skip to the end or skip around, find the ones you need. But I'm just going to be working through this. So number 2, we have a central angle. Let's go ahead and draw a circle. So central angle of 2 pi over 3. So 2 pi over 3 and a radius of 15 centimeters. Now what they're asking us to do is they're asking us to find S, the arc length. So we know there's 2 formulas for S. We have S equals theta over 360 times 2 pi r. So that's an equation we're going to use if we have degrees. The other equation, if we have radians, is going to be S equals just theta times r. So it's definitely going to be more advantageous to use this one since we're dealing with radians. All right. So they're asking us just to find S on this one. So it's just a matter of plugging it in. S, the arc length, this right here. All right. That arc length is just equal to 2 pi over 3, that's central angle, times our radius of 15. Let's take that 15, turn it into a fraction. Let's call it 15 over 1. This gives us 2 pi times 15 gives us 30 pi. 3 times 1 gives us 3, so 30 pi over 3. So that arc length as a simplified fraction is just 10 pi, all right? So from going from here to there is 10 pi. So that's how we do number 2. Going on to number 4 now. Oh man, let's see. After class, Angela says, I don't understand how he got the formula S equals theta times r. So basically, she doesn't understand where this formula came from. So what we have to do is we have to start out with this formula here. So if we start out with S equals theta over 360 degrees times 2 pi r, we have to start with this and end up here. Well, just kind of like a side note, we know 360 degrees, right? That's equal to 2 pi radians. So we're going to use this conversion. Right? Basically what we're doing is we're going to substitute this right here. So in doing so, we have S equals theta over 2 pi times 2 pi r. And again, we can take this 2 pi r and turn it into a fraction. If you notice, we have a 2 pi on the bottom of the fraction, a 2 pi on the top of the fraction. These cancel out. And if we just multiply what's left over straight across, we have theta r over 1. And since it's over 1, you don't even need that. So we can call this theta r. So an arc length S is just equal to the central angle in radians times the radius. Number 6. Number 6 says theta equals 2 pi over 5 radians. S equals 5 pi, and they want us to find the radius. Okay, so r equals question mark. So again, this is an arc length. All right, so we're going to use that equation. Since it's an arc length in radians, we're going to say S equals theta times r, and then just plug in what we know. Okay, we know S, the arc length, is just equal to 5 pi. Keep your equal sign. Theta is 2 pi over 5 times r. All right, now I think this is a part that's kind of throwing you guys off. So what I'm going to do is I can rewrite this. So we're going to call this 5 pi equals 2 pi r over 5. We're allowed to do that since it's just being multiplied together. So I'm going to multiply 5 on both sides. What we end up with is 25 pi equals 2 pi r. And then we can divide away the 2 pi on both sides. All right, you'll notice now pi's cancel each other out. Right, this whole side's gone, and we're just left with 25 halves equals the radius, or if we wanted that as a decimal, half of 25, that's just equal to 12.5. All right, number 6 is done. Let's look at number 8. Number 8, same kind of thing. So number 8, theta equals 7 pi over 4. S equals 28 pi, and they want us to find the radius. All right, so same exact thing as number 6. I'm going to plug everything in we know. 28 pi equals the central angle over 4 times the radius. Same process, multiply by 4. All right, that's going to be 25 times 4 is 100. That's 3 left over. 3 times 4 is 12. So that's 112 pi equals 7 pi r. All right, divide both sides by 7 pi. 7 pi. Let's see, we're going to get r equals, I don't know what that one is. 7. 112 divided by 7. 16. So the radius here is 16. All right, number 8 is done. Let's look at number 10. Find the measure in radians of a central angle that intercepts an arc of length 4 pi centimeters in a circle of radius 10. All right, so on this one, they're not drawing a picture for us, so let's just make one. All right, here is our central angle, or what is close enough to a central angle. We're going to call that theta. We don't know exactly what the central angle is yet, but we can figure that out. They're telling us the radius is 10 centimeters, and let's see, find the measure of central angle that intercepts an arc length. All right, so they're telling us this. All right, the arc length going from one spot on the track to the other, that has a distance of 4 pi centimeters. Okay, so now let's just again use that formula. We have s, the arc length, equals theta times the radius. All right, we have everything we need. These problems 6, 8, and 10 very similar, pretty much the same thing, just different numbers. All right, so 4 pi equals theta times our radius of 10. It's just a one-step algebra 1 problem. Divide both sides by 10. All right, so we're going to get theta equals 4 pi over 10. We can reduce that down to 2/5, or 2 pi over 5. So let's take a minute here and let's just kind of recap how we go from radians to degrees. So the question doesn't ask us for degrees. We could leave it like this. This is a perfectly fine answer. That is an angle measure. But maybe I were to say, take that 2 pi over 5 radians, turn that into degrees for me. What we need to do is we need to multiply this. We have a conversion. We know 360 degrees equals 2 pi. But we could simplify that if we wanted to. We could divide both sides by 2. And we have 180 degrees equals just a single pi. All right, so kind of using that idea. Since we're going from degrees, since we're going from radians to degrees, we need our radian units to cancel. All right, since we have a radian unit on top here, if we wanted to cancel the radian unit, that would have to go on bottom. So going from radians to degrees, put your degrees on top. Think about whichever one you want to end up with is the one that needs to go on top. Since I want to end up with degrees, I need to put my degree units on the top. So what we get is 2 pi times 180, 360 degrees times pi over 5 pi. Notice how the pi's are going to end up canceling. So pi's go away. 360 divided by 5, think that's 72 degrees. Let me double check. Yeah, okay. So 72 degrees. If we wanted to take this 2 pi over 5 and convert it into degrees, that's how we do it, right? So either one of these answers is an acceptable answer for whatever that central angle is. All right, that was number 10, halfway done. Now let's look at number 12, determine the area of the sector. All right, so number 12, let's kind of go over that formula. So area of a sector, we know the area of a sector is equal to theta over 360 degrees times pi r squared. That is the formula or the equation we have for degrees. Again, we know that, well, I'll save that for 14, but the other equation, the area of the sector, is also equal to 1/2 times theta times r squared. That is the equation if we are given radian units instead of degrees. So let's just use what we know. We know the radius is 4 centimeters. The central angle theta is equal to 5 pi over 3, and they want us to find the area of this sector. Right? So 5 pi over 3, that looks something like this. Right? So that is our central angle. We know our radius is 4. What they want us to do is they want us to find the amount of space in this piece of the circle. All right, they gave us radians, so let's use the radian formula. All right, so the area of this sector is just equal to 1/2 times theta, 5 pi over 3, times the radius squared. So radius squared, 4 squared is 16. So we'll just go ahead and say 16. And then to keep some consistency, let's call that 16 over 1. All right, so we're just multiplying a bunch of fractions. So 1 times 5 pi times 16, that's going to give us 50 plus 30, 80 pi over 2 times 3 times 1, it's just 6. Does 80 over 6 simplify? Not a nice number, so let's turn that into a fraction. We'll call that 40/3. So the area of this sector is 40 pi over 3. And you can leave it like that. We don't need a decimal. I mean, I guess we could if we wanted to, but that's not necessary. That is our final answer for number 12. Now, on number 14, somebody's asking something. Michael's saying he doesn't understand where this formula came from. All right, so just kind of like how we did with the arc length formula, we're going to do the same thing with the sector formula. So we know the area of a sector, that's equal to theta over 360 times pi r squared. And again, we know 360 degrees is equal to 2 pi. So we're going to do the same old swap here. We're going to say the area of the sector is equal to theta over 2 pi times pi r squared. Let's go ahead and turn that into a fraction, because why not? That's going to give us theta pi r squared over 2 pi. All right, now notice how the pi's cancel in this case. So we are left with theta r squared over 2. Okay, now to go from this to the very next one, instead of saying divide both of these things, instead of dividing theta and r squared by 2, let's just pull it out front and multiply it by 1/2. I mean, that's going to be that's really useful tool, just being able to take that and writing it as its own unit. 1/2 times theta times r squared. All right, so that is how we go from this equation to that equation. All right, so think 360 degrees, this is the equation we use for degrees. Doesn't have degrees, so we don't use the degree formula. This is our radian formula. All right, number 16, here we go. 16 says the area of the sector is equal to 6 pi, central angle is pi over 3. Let's plug in what we know. We're looking for the radius again. All right, so we have 6 pi equals 1/2 times pi thirds times r squared over 1. Let's see, 6 pi, that's going to be pi r squared over 6. I'm out of room here. I'm going to go up here. All right, so multiply both sides by 6. You're getting 36 pi. 36 pi equals pi r squared. Divide both sides by your pi. The pi's cancel. So we're left with 36 equals r squared. How do we kill a square? We square root both sides. All right, so the radius on this circle is just equal to 6. Plus or minus 6, but we can't have a negative radius, so positive 6. All right, 16 is done. 2 more. 3 more. Shoot, which one did I just do? I did 16. All right, time for number 18. Area of the sector AOB. So I'm going to draw a circle. Wait, this is number 18. Area of sector AOB is 10 pi, and measure of AOB is 100 degrees. All right, so 100 degrees might look something like this. So we have 100 degrees here. Area of this thing area equals 10 pi. Again, find the radius. All right, so they're giving us degrees this time. So we're going to say the area of the sector is equal to theta over 360 degrees times pi r squared. So we have 10 pi equals 100 over 360 times pi r squared. Here's what I'm going to do. I'm going to do a couple steps in one go here. I'm going to simplify this as 10 over 36. We go ahead and cancel out these pi's. So what we have is 10 equals 10 over 36 times r squared. I'm going to multiply by the reciprocal here. So I'm going to multiply by 36 over 10 to cancel out this fraction. Most important rule of algebra, whatever you do on one side, you got to do to the other. So if I multiply this side by 36 over 10, these 10s cancel out. We're just left with 36. 36 equals the radius squared. Again, square root to get rid of the square, and you have the radius of this circle equals plus or minus 6, but since it's a radius, we can't have a negative radius. We're going to stick with the positive answer. That is number 18. Number 20, here we go. Number 20 says the length of an arc of a sector, oh boy, length of an arc of a sector is 3 pi over 2 is a radius of 1.5. Find the area. All right, so this is going to be an easier one. So I'm going to draw find the area of the sector. Okay, I'm going to draw a central angle. Here we go. Here's my central angle. I don't know the area. That's what I'm looking for. I don't know the central angle, but I do know the radius. Radius is 1.5, and I know the arc length, so I know this piece right here. I know that's equal to 3 pi over 2. Okay, so we need, let's see here, if I'm looking for the area, I know the area is equal to 1/2 theta times r. I know the radius is 1.5. I don't know the area, and I don't know theta. All right, so this is going to be a two-step problem. We need to find theta first. Since they do give us an arc length, we need to use that. We know the arc length is equal to theta times r, the central angle times the radius. Okay, so plugging in everything we know, we're going to have 3 pi over 2 equals theta times 1.5. Okay, let's see, 1.5 as a fraction is 3/2, so, well, let's just do this. Divide both sides by 1.5. We don't need a calculator. 3/2 is just 1.5, so we have, dividing by 1.5 on both sides, we have theta equals pi. Now, using this, plug it in to this area formula. We have everything we need. So the area of this sector is equal to, area of this sector is equal to 1/2 times pi times 1.5 squared. 1.5 squared, I don't remember what that is. This can be an ugly decimal. We can get a decimal, we can live in terms of pi. I'd be okay with either one. 1.5 squared times 0.5 times pi, multiply all that together, that gives us 3.53. Do we have a unit on this one? No. All right, so that is our final answer. The area of this sector, this piece of pi, this piece of the circle, is equal to 3.53. All right, one more. Number 22. I made a separate video for 24 because that one's a little involved, so don't forget to watch that one. All right, number 22. Here we go. Circle O. What are we doing here? Find the area of the shaded region. We know this is a 90-degree angle, okay, but we don't want this one. This right here is our theta. We are looking for this shaded spot right there. Okay. So theta, we know there's 360 degrees in a full circle. So theta is equal to 360 degrees minus the rest of it. We know that this is a 90-degree angle. So minus 90, 360 minus 90 is 270. Okay, so theta equals 270 degrees. We know the radius. Radius is equal to 8.4 centimeters. So we have everything we need. The area of this sector is equal to 1/2 times 270. Wait a minute. No, we don't. Hang on. Wrong formula. The area of this sector is equal to 270 over 360 times pi times the radius squared times 8.4 squared. All right, we can plug that whole mess into our calculator. 270 divided by 360 times pi times 8.4 squared equals 166.25. So the area of the shaded region is equal to 166.25 centimeters squared. That was number 22. All right, and like I said, number 24, this problem, we got some circle. We have an equilateral triangle right here with a side length of 8, 8, 8. And what they want us to do is they want us to find the area of that red part of that shaded region. All right, so basically what we need to do is we need to find the area of that triangle and subtract it from the area of the circle. And I made a separate video on that one. That one's pretty tricky. See if you can try it yourself, though. you're going to need to use some stuff that we learned about last semester. So take a few minutes to think about that one before you watch that video.